Previously, we had been dealing with trophic levels, the producers to the consumers, and then that, the herbivore, carnivore. So we're seeing materials, we're seeing energy, we're seeing materials flow from one feeding level to the next feeding level. And so as that conversion from one level to another goes on, well, sometimes we can be carrying along things that we don't necessarily hope to carry along. And so toxins. So a few pages later in the notes, toxins. And so what are they? They are things that are going to disrupt the metabolic activity of your body. And if it really disrupts it too badly, well, it could damage or kill you. All right. And so we think about things that might disrupt our metabolic processes that are good. And this is when you go to the doctor and they give you drugs. Oh, I have high blood pressure. Well, let's give you something that will disrupt your pathophysiology and bring you closer to what we hope is normal metabolic processes, normal physiology. And so, yeah, things that disrupt your processes don't always have to be bad or kill you. But when we're talking about toxins, that's what we're interested in. Those processes that are interrupted that are going to damage your body. You're not functioning the way you should. And so some things that are kind of common, well, arsenic, lead, mercury, vinyl chloride, PCBs, polychlorinated biphenyls. These are all things that, would come to mind when you think about toxins, all right? And so we can put different categories, classify the toxins in different ways, and we'll start out here with allergens. And so inflammatory response, that's what an allergen does. And so, somebody who has asthma, they're breathing and they're having a reaction. It's their body overreacting to something that's probably in the air. And so, yeah, if you have, asthma, you're swelling up that tissue in your lung, and it's making it harder for the oxygen to diffuse across that respiratory barrier. You're filling up with fluids. It just makes it more difficult to actually get rid of the CO2 and bring in the O2. And so, there we see an easy allergic reaction. But, you get, some kind of toxin on your skin, poison ivy, poison oak, things like that. And, well, your body is trying to get rid of the stuff by, diluting it, right? Increase the blood flow, have the tissue swell up, increase the temperature, because the faster the metabolism, usually these things are good things if you have some sort of, bad thing happening to your body. You want to get rid of whatever is bothering you by diluting it down. But, inflammatory response taken too far can be just as bad, right? Talk to the asthmatic. All right, here we have examples. Formaldehyde. If you have, industrial processes where, we're making our plywood and we're using formaldehyde during the manufacture. Well, somewhere down the line, you put all that plywood up in your building and some of that gas starts to leach out. It gets into the air and you can have sick building syndrome. It's not just formaldehyde, it's all kinds of stuff. Carbon monoxide here, if you don't have proper ventilation, well, if you're in the building, then you're going to get sick. This is carbon monoxide, something that comes out of poorly burnt fuel. And so, if your furnace isn't burning as well as it should, as efficiently as it should, and you're not venting it out through the chimney like you should, then carbon monoxide can build up. That's why we have carbon monoxide fire alarm, detectors in the home along with the fire alarm. If you were to take the hose from the back of your vehicle, it's running in the garage, and run the hose into your car and, close the door in the car and Well, you just build up the CO2 gas. That's one way that, people can commit suicide, because carbon monoxide poisoning basically will replace the oxygen, and you don't have oxygen circulating in your blood anymore. It's being taken place by carbon monoxide. Mold, if you have, your house, saturated with water, there was a big flood or a hurricane and you had all this water, well, mold can start growing on the walls in your house or in the walls of your house. And well, now the mold spores, they're getting out into the air that you breathe, and yes, you can have an allergic reaction to the mold. So sick building syndrome, it can happen. When I was an undergraduate, they built a chemistry building, 17 stories tall. And so it had one of the, wonderful, let's not be able to open any of those windows and have ventilation all taken care of internally. Well, that sounds like a good idea, but it didn't take too long after that before sick building syndrome, because pretty much no matter how you calculate the airflow that you need, it's just never going to be enough when you have all kinds of experimental chemistry going on in your building. And so sick building syndrome, it occurs. You gotta be aware of it. Here, endocrine, before I go, food allergies, right? These will cause inflammation in your intestine, things like that, if you're eating it, or anaphylactic, the closing of the respiratory trackway, just bad news. And so big 8 allergens, and so yeah, you got your nuts, peanuts, soy, milk, wheat, and shellfish. Somebody is allergic to one or more of these. And of course, there are some kids that are allergic to probably all of them, and so I don't know what they end up eating. But here's a little picture, and yeah, it looks all innocuous as you're looking at it, but to somebody, there's going to be an allergic reaction from any one of these things. How can milk be bad for you? But for somebody, it won't be. Okay, seasonal allergies, yeah. And so pollen in the air, when you look at the time of year, grass pollen, really, really high during June and July. Mold spores in January, and then summertime. Mountain cedar, pecan trees, ragweed. So we got different times of the year when, allergies, things going through the air, causing inflammation of a person's respiratory tract. Let's see, well, how to tell allergies from a cold. Okay, we don't need to worry about that. What do you do? Antihistamines, right? These are kinds of things that are going to reduce the swelling, the inflammation, right? Histamine is something your body puts out that, opens up blood vessels and allows kind of a flushing out of your tissues. And so, well, you might want to avoid flushing out your tissues and making the interstitial spaces between your cells get all fluid filled, right? Edema. Allergen exposures, again, you could almost call this part of sick building syndrome too. But you look at, infestations of dogs and cats in these parts of the country in particular. Those infestations of these animals could make your allergies worse. Dust mites here on the western or on the eastern side of the country, but rats and mice, well, not so bad, overall compared to dogs and cats. But, cockroaches here, yeah, a little bit higher levels. And so cockroaches, yeah, they're going to end up, being allergenic. The little dust left by the feces in particular of the cockroaches going everywhere, dries out, gets into the air. You don't want to have to deal with that stuff. So keep your house clean as best you can. Okay, moving on. Endocrine disruptors, they disrupt or they enhance the effects of hormones. And so what are hormones? Well, they are chemical messengers in your body. And so often we think of estrogen, we think of androgens, you know, testosterone would be an androgen, estrogen, of course, estrogen, progesterone, and estrogen material. And so these are things that give us our tendency to develop our sexual characteristics, right? Our secondary sexual characteristics in particular during puberty. So high levels of you know, hormones, of sex hormones, are going to have a major effect on us. Okay, but you know, hormones in general, you got all kinds of hormones. The thyroid gland I mentioned before, producing the thyroxine, and that increases your metabolism. So these are chemical messengers that basically travel through the blood, and when they hit their target organ, for thyroxine, it's all the cells hit your target organ, and then your target organ or cell is going to start doing whatever it's been told to do. By thyroxine, increase metabolism. In the sex hormones, increase your tendency to have more mature sexual organs or whatever those cells are. And so now, when we talk about some kind of chemical that comes in and acts as a toxin, it's going to be disrupting. It's going to actually, you know, do something to either stop or increase the effect of those sex hormones or of any hormones. So what we have here, estrogen-like compound binds to receptor and blocks the estrogen uptake, right? So here's the estrogen-like compound. That's a disruptor. You want the estrogen to actually attach onto your cell wall. Here's the cell. And you want then the internal workings of the cell to respond to the hormone that has come and told the cell, hey, do something. But here, this will bind to the same exact spot, the receptor on the cell, and it will prevent, right? This is going to be in the way, and it won't allow the cell to continue on with its purpose, with its metabolic process. So, endocrine disruptors. Let's get that out of the way. The disruptors can increase the effect or decrease the effect. Basically, it can feminize males, masculinize females, depending on what's going on. So many of the disruptors are really estrogen in their effect. So they tend to have a lot of the feminization going on. And so something that really came to the forefront starting back in the late 70s, early 80s, people started noticing that they'd go out, they'd collect the fish out of a stream or out of an estuary or bay, something like that, and then they'd start opening up the fish to look inside to see how things are going. And well, it ended up that you have an awful lot of male fish that have testes, and in the testes there might be eggs developing, or females that have sperm developing. That there's some kind of problem going on, that we have some sort of intersexuality in the gonad. The gonad is the primary sex organ, either the testes or the ovary. So gonad, just a generic term for sex organ. Well, you can't have this. They're not going to reproduce like they should. And if it's a fish that is, something that is marketable, this is not going to be good for the long-term population structure of your fishery. And so they were seeing this in fish, they were seeing it in the oysters, feminization of male oysters so that things were disrupted, all kinds of problems. Now, why would this occur? Well, there's all kinds of pollutants going into the waste, into the streams. So PCBs, they can be endocrine disruptors, dioxin. This is, something from an industrial pollutant. You have all the stockyards where they're injected with hormones in order to increase growth. Well, not all those hormones that are injected into the cows and the pigs and whatnot end up staying in the cow. They just pass through in the urine and the waste. And well, if you have a stockyard where you've got all the materials being expelled, the runoff goes into the streams, into the rivers, and well, now the poor little fish, the amphibians, the clams, they're all exposed because they basically are living in the water. And if the water is polluted, they're going to have problems. They're going to be absorbing all the pollutants. And so this really started getting noticed, in that early 80s or so. People started writing papers, odd feminization of our male fish from this stream, from that stream. And it ended up being all over the country because there's pollution all over the country. Different causes. In Pennsylvania, there was a famous river that basically had, all these intersexual organisms in it because, well, upstream was a pharmaceutical company that was producing the pill, right? So, something to prevent, the reproductive process in humans. And so a lot of wastewater coming out, dumped directly into the streams. At which point, well, now you're getting all those, products, the waste of the manufacturing of the pills, now going not to, the people who are paying for the pills, but, to the little fish in the ocean that don't want this. Okay, so, they were noticing all this happening all over the country and different reasons for why it was happening. All right, neurotoxins. Instead of targeting, sex organs and that whatnot, neurotoxins target the nervous system, right? So hormones, they're kind of a long-term regulator of the body. Here, you're looking at neurons, nervous system, very fast regulation. I want to move my arm. Okay, I told my muscles to move it. How did I tell it? Through the neurons, through the nerves, all right? And so nervous system function can be disrupted. And so here's an example with lead down there, but one that you might recognize. Well, here's a movie, The Mad Hatter, and look at that lovely hat right there. And then, well, we recognize this character from so many of the movies. I don't know, what's his name? Johnny Depp. Yeah, okay. And so, if you saw that movie, Alice in Wonderland or The Mad Hatter, whatever it was called, what gave the Mad Hatter the term Mad Hatter is at the time, 1700s, you'd have the people making the hats using an awful lot of mercury to tan, right? And so you get your beaver pelts, they need to be tanned. They need to be made into something pliable that you could work into a hat. And so you used an awful lot of mercury. So they were exposed to mercury as an occupational hazard. Nobody knew that it would, cause problems and eventual madness as their nervous system was destroyed. Well, there you go, the Mad Hatter. Well, other toxins, well, we have all kinds of heavy metal toxins, but lead is another one here. you know, as well as here's liquid mercury. Arsenic up there, well, you know, arsenic just as a poison in general. You know, you use arsenic to kill small animals, things like mice or cockroaches or whatnot. Neurotoxins specifically target the nervous system. Let's see if I can find, oh, I think I put it away. Oh, no, no, there I go. All right, and so specifically dealing with heavy metals, so toxins here, we go over and yeah, children most vulnerable to lead poisoning. 2-year-olds have the highest blood level concentration of lead, partly because of they put too many things in their mouths. And so when you go and buy a house, you'll see that there will typically be some kind of lead paint warning, right? And so you have to sign paper saying that you're selling the house and you don't know if it has lead paint, or you know it does not have lead paint, so it's safe. The deal is there's paint that was made before the 1970s or so, and I think 78. You know, before 1978, paint often had lead in it because it was really good as a binder, and you know, made nice paint. But you know, the thing is, when the paint starts peeling, well, little children are there. There's the windowsill, a lot of weathering going on, peeling paint. Let's eat the paint chips. Kids will put anything in their mouth. And so the paint actually has a little bit of a sweetness to it also. And yeah, who can not eat lead paint then, if there's some around? Well, all right, this ended up given all kinds of problems to small children, their development. It caused neurological effects, things that you don't want, you know, in your growing children. And so IQs dropping in children when they, you know, look at it. And of course, you know, when you have a small child that, you know, doesn't have as good a cognitive ability, they probably also are going to have other troubles dealing with concentration, dealing with behavior. And so, yeah, we have all kinds of, you know, problems with children. Mercury, another heavy metal that, you know, somewhere here. Many people concerned with mercury level in fish. And so, you know, you want to, if you're a pregnant woman, don't eat the tuna fish, because tuna fish, we'll talk about later, they bioaccumulate, right? They get a lot of mercury in it, because if there's any mercury in the environment, it's going to be really concentrated in the highest predators. So don't eat sharks, mackerel, swordfish, or tilefish if you are susceptible to mercury poisoning, which a little fetus would be, all right? So a little fetus, especially vulnerable, mercury poisoning. So don't do that. Let's see, we can move on. There's carcinogens. Oh, here's endocrine disruptors, right? Endocrine disruptors here. And, you know, bisphenol A here, that's something, synthetic estrogen used in plastic manufacture to harden polycarbonate plastics and epoxies. And so when you go buy your baby bottle, often they'll say on it, BPA free. Don't buy your baby bottles with BPA as part of their manufacturing process. And of course, you know, now 6 billion pounds of BPA produced annually globally, generating about, you know, $6 billion in sales. BPA is going to be with us for a long, long time, just as all the plastics in the ocean are. All right, so, you know, there we had an endocrine disruptor, and phthalates, you know, used to soften and increase flexibility of plastics, particularly PCB. And so again, you know, you got all the bottles and food that are packaged in with the phthalates as part of the manufacturing. So you got to be a little careful about how much of that kind of stuff that you get. Oh, let's see. Well, let's come back to this a little bit later. We saw a couple of the neurotoxins within the paper there, and that's fine. We go next, mutagens. Mutagens are going to be things that cause your DNA to break, and then when the DNA tries to repair itself, it may not repair itself real well, and now you have some kind of damaged DNA, a mutation. And we get mutations all the time in all the different cells in our body. There's no cell that doesn't get a mutation somewhere, but for the most part, the mutations are going to be harmless because we have so much DNA that doesn't even do anything that, yeah, if you break it here and it doesn't repair itself well, no big deal because you're not using it. And, you know, if it's a pancreas gene, you know, that gets mutated, but the cell that it gets mutated in is in your skin, so what? Because your skin isn't going to be using that pancreas gene. So what does cause a problem when you have mutations is when you have something that is going to regulate the growth of your cells, right? How often is that cell going to reproduce, and what's going to stop it from over-reproducing? If you end up damaging your DNA in a cell and it manages to disrupt one of these growth genes, then you can actually get a cancer, right? Because, oh, the growth is disrupted. And so you might just keep reproducing and reproducing and reproducing, and a tumor grows, you know, or you might not be able to stop the growth because the stop gene is no longer functional. And so, you know, if that happens in one or two little cells, you might be able to take care of it with your immune system, but you know, what if the immune system doesn't recognize that as being an odd cell? Well, then you get the little cancerous growth. And so you can damage the DNA, and if you do it during development, right? You're an embryo or a fetus, and the DNA is damaged, well, now you're going to end up having a birth defect of some sort. And we tend to call this teratogens. So a teratogen is a birth defect that, you know, affects your ability to survive, right? And so here, alcohol, that's one of the teratogens that, you know, might affect a small child, fetus, when the mother drinks too much. Remember, you know, when you're pregnant, you're not supposed to be drinking a whole bunch of alcohol. It's best not even to drink any, you know, be safe. But, you know, here, you know, here's a child that, you know, did not end up having too bad of a problem. They lived, right? And so a lot of teratogens, you end up having miscarriages, abortions, natural abortions. But, you know, the ones that might have been disrupted somehow and managed to live, well, they're lucky ones. They survived. But, you know, some damage gets done. And so here, you know, are some of the things that, you know, for fetal alcohol syndrome, you might expect to end up seeing, you know, in the face. But there's also damage to the internal organs. Heart problems are going to be more common. There's going to be brain damage. There's less likelihood that that child is going to go on to win a Nobel Prize because, you know, damage to the neural system. Mercury, same kind of deal. You can get all kinds of teratogens. After you're born, here's where you often can get cancer from carcinogens. So carcinogens, you smoke a lot, well, there are all kinds of little chemicals in that smoke that you're inhaling. And some of those chemicals, they can disrupt the DNA, break the DNA, and well, it tries to repair itself. And essentially, after a lifetime of smoking, usually it takes about 4 different genes in the cell to have mutated, and then things go wrong and you get lung cancer. Okay, and so carcinogens, these are chemicals typically from the environment. You know, it can be a social type thing like the cigarette, or it could be, you know, an industrial thing that gets dumped into your drinking water. could be the arsenic in your natural arsenic in drinking water. All these things can give you a DNA problem and lead to cancer. Radiation, sunburns. The UV radiation, too intense, burns your skin, and so you might end up being susceptible to skin cancer because the UV radiation ends up being just the right size of energy radiation to break DNA. So DNA is susceptible to breakage from UV radiation, leads to more frequent cancers of the skin. All right, and so, environmental teratogenic agents, all right, so getting a teratogen, birth defect in genesis, the beginning. All right, so toxins cause abnormal development, classified as genetic or environmental, radiation, metals such as methylmercury, ethanol, alcohol, nicotine, cocaine, all these things can have an effect on children's development. So yeah, we can, look at all this. Neurological problems, dementia, stroke, neuropathy, cardiovascular hypertension, just all kinds of problems. Thalidomide, a sedative drug, gave you the thalidomide babies, where this teratogen ended up, before they realized, thalidomide ended up being real good to take care of morning sickness, but nobody realized that it was also a teratogen, and so lots of little babies born with tiny little arms. It disrupted their arm growth, at which point thalidomide really got taken out of circulation for a long, long time. Now they can use it for nausea and stuff, but it's not something that you would give a pregnant woman. And so other kinds of environmental things, examples of toxins, here they're showing us just all kinds of places where, hairspray, some of the toxins, allergies, irritation to eyes, changes in cell structure, deodorants, aluminum, zirconium, I don't know what that does, but it's probably going to, dry up your arm or something. Organ irritation, hormone disruption, oh my goodness. So you look and see all kinds of body lotions, side effect rash, irritation, hormone disruption. Here, something linked to cancer for perfume, all those different chemicals. So it just doesn't matter, if you just are alive today and somewhere in the environment, you're going to get toxified one way or another. Oh, let's see. The next little topic here I want to go over real quick. We have bioaccumulation. And so we've kind of classified different kinds of toxins, but now let's think. When we take these materials into our body, we're going to, send them through a tube. Actually, from your mouth down to the other end, that tube that goes all through your body technically is outside of your body. You have to be able to take the stuff that you swallow and actually absorb it into your body from the digestive tube. And so until it crosses that intestinal barrier or the stomach or wherever, it's still outside. Even though you're surrounding it, that food material is outside. And so you eat a piece of bread, it has some fat, carbohydrate, protein, all kinds of other little stuff in it, and it has fiber. And so as it goes through you, the fiber is not going to be broken down. You can't absorb it. The sugars and stuff, you can break that down and absorb it. And that is good selective absorption. And we're taking this and, hey, let's take that, glucose, the sugars that we've brought into our body, the fats we brought into the body, let's store it in our fat cells or in our liver as glycogen or something. So we're absorbing and storing things that we like, But now we come back to the toxins. And so we start eating and eating and eating. And well, if there's a little bit of the toxin, it can accumulate. And it can accumulate and not necessarily just pass through you, but be absorbed. And just like the fats and the sugars, it can be stored in your body. And so a lot of toxins end up getting stored in your body. Big problem, a lot of the storage ends up being in vital organs. And so you go out and start fishing, oftentimes, like Lake Erie, along the industrial shore of Ohio, Pennsylvania, New York. You just had millions of tons of toxins pumped into Lake Erie, poisoned the fish, just made it into a cesspool of toxins, and people could not eat the fish for the longest time, because if they did, it would toxify them. The toxins were, accumulated by being absorbed by the plankton, the algae, the little fish. They would eat the little zooplankton, the little algae, all the other kinds of tiny, minute organisms. And so the fish started accumulating. Little tiny minnows accumulate. Well, then the big fish eat the little fish. And as the big fish eat the little fish, well, they're processing and they are absorbing the toxins and they're accumulating. And we just keep accumulating more and more of the toxins. And as we go up the level of the food chain, we just keep adding and getting more concentrated toxins. So here, if the environment is some incredibly small part per million here, well, at the next level, we've accumulated a lot of the toxins. We basically have filtered it out of the water, and it's now in the little plankton, now the little fish, the big fish, and then finally, here's kind of the apex predator, the eagle, the osprey, the falcon, whatever it is that you got up there. Now in them, the accumulation has been magnified. So it's bioaccumulation and biomagnification both. So magnifying, you're increasing the concentration levels. All right. The best example of that deals with DDT. So let's see, dichloro-diphenyltrichloroethene. And so you look for, that mouthful of word and say, how can I, get that to be shorter? DDT. All right. So DDT, a wonderful chemical discovered by Paul Mueller in 1938. And, we used it for years and years and years. It was great to get rid of all kinds of pests that were eating your crop. You got locusts coming through, put down a bunch of DDT. That will kill the locust. It basically would kill anything that tried to eat it. And so, during World War II, you had all those mosquitoes, right? And you got all those servicemen out there in swampy areas. And, well, you don't want them to get things like yellow fever, malaria, things that are, carried by the mosquito vector or flies or whatever might be a problem. Use DDT to get rid of all those things. It was a wonderful, wonderful chemical, and it particularly became more and more used, throughout the 60s, 70s, 80s. But then in 1962, Rachel Carson, right? Here's Rachel Carson. And we'll talk a lot more about Rachel Carson. She was kind of a popular writer, very famous during the late 50s, early 60s. She died in the mid 60s there. She had breast cancer. But She had been, somebody that had gone to work in the fisheries department, U.S. government fisheries, and was really renowned for her ability to write for the public, and wrote several books. The Sea Around Us was one of her first books, and so there's a lot of, Rachel Carson, quotes and stuff from her popular level books. But the one that mostly everybody is going to focus on when they talk about environmental science is Silent Spring. So here's the cover of Silent Spring. And what it was about was essentially, let's look at the effect of DDT. And so DDT in great use agriculturally all through the United States, worldwide really. And she showed us that the effects of this went beyond just killing the agricultural pests. We see bioaccumulation going up the trophic pyramids, and it was affecting not just the insects, but anything that ate the insects, anything that ate the birds that ate the insects, anything that ate the plankton that got eaten by the fish that ate the fish. And so things like the condors, things like the bald eagles, things like, whatever raptor was out there that was at the top of the apex of the pyramid, these birds were dying, and their populations were dying because the DDT was accumulating in their bodies, and what effect this had was to make the shells of the egg so brittle that if you sat on the egg, you as the mother eagle broke the egg. The shell was so fragile because of the DDT. I mean, there's all kinds of other problems going on internally with these animals, but that was the big effect. And so why were there no songbirds singing in the spring? Why was it silent? Well, because the birds were eating the insects, which were dying from the DDT, and they were being poisoned also. And so, because of Rachel Carson and her environmental work, we end up getting rid of the DDT in 1972, at least for agricultural use. If you need to use it for disease control, you can still do it, but it's not allowed in agricultural to be sprayed over your fields anymore. And so, there's still all kinds of false controversies, false facts going on today as people are trying to denigrate the ban on DDT, and there'll be all kinds of lies that you hear. And we're going to, talk about that in its whole own episode later on, because it's good to be able to objectively look and evaluate different arguments from different groups of people and why they would argue that, oh, we should never have, ban DDT. Now, money, right? Money. Okay, and so DDT, organic pesticide, it's lipid soluble. So, it may not stick in water all that well, but it can get absorbed and stick around in your body fat for quite a long time. The soil half-life, 10 days, 30 years. Is there a lot of rain? Is there a lot of heat? If it's kind of a semi-dry, cooler soil, the DDT will persist for a long, long time. Low metabolic breakdown, half-life in humans, 6 to 10 years. So if you get a dose of this, you look at your grandparents who might have been around in the 1970s, they very well could still show a fair amount of residual DDT in their bodies. Hopefully you haven't been around DDT for much of your life, although we can't guarantee it. There's a lot of residual in the environment. But okay, hopefully the DDT isn't going to be a concern for for too terribly long because we have tried to reduce our amount. Okay, what's this all about? Sources of heavy metals cycling in soil, water, air, organism, ecosystem. And so, yeah, all right, we got all the industrial, we got the rocks. Remember, things like arsenic, mercury, you can find them in rocks. How do they get into the environment? Well, through the air, the soil, the water, that gets into the plants, that gets into the organisms. So, soil, water, air, organism, and then it gets into the humans. And what do they tell us here? The content of metals in tissue generally builds up from left to right, indicating vulnerability of humans to heavy metal toxicity. And so, yep, the heavy metals, they do get to us by all of these different ways. Oh, I was going to mention about the fish. Lake Erie, so many toxins are in there. If you go to Lake Erie today, they cleaned up, right? So much of the industry, kind of had, gone downhill that, there wasn't so much pollution being added. And eventually, a lot of the pollutants did get cleaned up. Lake Erie is still, full of toxins, but not anywhere near as it was before. But if you go to Lake Erie and go fishing, don't eat the internal organs of the fish or give the internal organs to, your dog or cat or whatever, because you accumulate the toxins in your liver, your kidneys, those internal organs, more than you do the muscle. If you're eating muscle, it's a whole lot safer than where you have accumulation of your nutrients and the toxins. Okay. Oh, and just for fun, 10 most common toxins for cats, just like that picture with the woman with all the makeup and perfumes and all the other stuff that basically can, ruin your life through toxicity. Here, all the things that can become toxic to cats, the flea prevention, put too much on your cat and you can toxify the cat a little, might save them from the fleas and disease like that. But, you don't want to give your cats aspirin and stuff here, toxicities of Christmas. And, there's the dog and the cat in their little Christmas hat. And, well, you don't want to give them grapes and raisins, chocolate, sugar-free products. Well, I don't know. Apparently these things are toxic to the animals. Mothballs, yeah, you could figure that one out. Antidepressive drugs, no, you shouldn't be giving them to your cat, dog, even if they get depressed over the holidays. And then, let's see down here. Yeah, acetaminophen. Yeah, these are the kinds of things that you don't want to, feed to your dog, cat, unless you want to get rid of them. And, well, no, that's the wrong thing to do. All right, so enough on the basics of toxins. We'll go on to talk about, DDT and Rachel Carson later on, but that's enough for now. I'll talk to you later.